Here's like what's going on in alpha. You see it's producing this helium. Um, so with these little formulas, there's a couple things that you need to know. This number right here is the mass number for the element, that top one. Now, I did see on this test that you don't actually have to do any math or any short answer questions on this nuclear test. So that's, good if you're not a short answer person, but not so much if you prefer the short answer to the multiple choice. So all of these top numbers, these are called the mass number. And then this bottom is the atomic number. So like I used to teach my students that sometimes they would have a formula and they wouldn't give you this part. Okay, so you could do, let me see if I can get a 2. You could do 238 minus 234, and you get 4, and that's that top number right there. That's what that was. And then you can do 92, which is the bottom, minus 90, get 2. So you've got 4 over 2, and then you could, go to your periodic table. You could see that that was a helium atom, and then you would know that you've got alpha radiation. I didn't see anywhere where they made you do this math like this, but they did want you to know. They did want you to see these formulas. In fact, this formula, this graphic itself, came from the test. This one did not, but it's the same thing. It's what would happen in beta radiation. This is still your mass number. That doesn't change on the top. And this is still your atomic number. But you can see instead of a He at the end, we have an electron. And so it's a mass of 0 basically, because electrons are tiny and they don't really have any mass compared to protons and neutrons and atoms. And then the charge is -1. So because 6 minus 7, right, would be -1. So if you saw this, you didn't have the beta here. You said, oh, -1, an electron. Oh, that must be beta radiation. So they might do something like that. They might give you an equation like this and then ask what type of radiation it is. And so this would be a formula with fission. You can see we've got one element here, uranium, and it's separating into these two elements. I want to say that's krypton and maybe barium. I don't know. Like I said, I don't have these memorized. It's been a while since I taught chemistry. Now, one of the things your test asked, which was I thought kind of like a weird question, is they said, what does this 3 stand for right here? And you see you've got this like 1 neutron there, and then you have 3 here. So what this is saying is this is saying that for each reactant, for each uranium atom, you're going to have this happen 3 times. Okay? And so that's kind of what's going on. That's what that is telling you. And so this is your neutron. You've got 3 neutrons, and then this E stands for energy. And this is the part that we want. Okay, so this is a fission reaction. You can see you've got one thing and you're breaking it into 2. So that's how you can tell it's a fission reaction. You just kind of have to just look for the elements and kind of tune out the other stuff. And then if we want to look at a fusion, you can see we've got 2 things and we're turning them into 1 and we're releasing energy. Okay, so this would be The other one was like a decomposition reaction. This would be like I don't remember what the chemistry word is actually for you're putting two things together. But you can see that you've got two reactants and then the one product. So that would be a fusion reaction. And then this is that term transmutation that we talked about before, where you've got one element turning into something else, right? It's turning into TH and helium, whatever TH is. That is not a common one. And so this is what's going on with uranium when it is decaying. And so because it's turning into something else, they call it, the actual word for that is transmutation.